chemical names for halogenated refrigerants are long and cumbersome. In order to avoid confusion and the proliferation of different numbers for the same product, a numbering system was required to be developed and also accepted by the industry. This gave rise to the R-nomenclature of refrigerants, which has been formalized as ASHRAE Standard 34. Each refrigerant is assigned a unique number which is related to its chemical composition based on some rules. The numbering system rules will be discussed in this video. Let us start with organic compounds. Say there is an organic compound with this chemical formula, where A, B, C and D are the number of atoms of carbon, hydrogen, fluorine and chlorine respectively. The identifying number consists of R followed by 4 digits separated by a hyphen. R is the acronym for refrigerant. The first digit on the right is the number of fluorine atoms. The second digit from the right is 1 more than the number of hydrogen atoms. The third digit from the right is 1 less than the number of carbon atoms in the compound. When this digit is 0, it is omitted from the number. The fourth digit from the right is equal to the number of unsaturated carbon-carbon bonds in the compound. When this digit is 0, it is omitted from the number. Let us consider the example of trichloromonofluoromethane, which has a chemical formula CCl3F. Thus, the number of chlorine atoms in this compound is 3. The compound has 1 fluorine atom, so the first digit on the right becomes 1. The compound also has 0 hydrogen atoms. This makes the second digit from the right also equal to 1. In this compound there is 1 carbon atom, so the third digit from the right becomes 0 and will be omitted from the number. This compound also has no carbon-carbon unsaturated bond, so the fourth digit from the right is also 0 and will be omitted. Hence, the identifying number for the compound is R11. Let us see another example of bromo-trifluoromethane, which has chemical formula CBrF3. Here, there is no chlorine atom and we have 3 fluorine atoms, which makes the first digit from the right equal to 3. The compound has no hydrogen atoms, which makes the second digit from the right equal to 1. The compound has 1 carbon atom, thus the third digit from the right is equal to 0. Also, the compound has no unsaturated carbon-carbon bond, so the fourth digit from the right is also 0. However, this compound also has a bromine atom. In such cases, a suffix uppercase letter B is added to the designation to signify the presence of bromine. A number follows this uppercase letter, which indicates the number of bromine atoms present in the compound. Hence, the designation for this compound becomes R13B1. In those instances where iodine is present in the compound, the same rules apply, except that uppercase letter I is added after the designation of the parent chlorofluoro compound, showing the presence of iodine. The number following the letter I shows the number of iodine atoms present. Now let us consider a case where we need to find the chemical formula from the given R nomenclature of the refrigerant. In this case, the first digit from the right is 3. Hence, the number of fluorine atoms in the compound is 3. The second digit from the right is 2. Hence, the number of hydrogen atoms is equal to 2 minus 1, that is 1. The third digit from the right is 1. Hence, the number of carbon atoms in the compound is 2. There is no fourth digit from the right, which means it is equal to 0. Hence, the compound has no unsaturated carbon-carbon bonds. Also, we do not see any uppercase letter with the number. which means there are no bromine or iodine atoms present in the compound. However, the compound may or may not have chlorine atoms. The number of chlorine atoms in the compound is found by subtracting the number of fluorine, bromine, iodine, and hydrogen atoms from the total number of atoms that can be connected to the carbon atoms. For saturated refrigerants, this number is 2A plus 2, where A is the number of carbon atoms. The number is 2A for monosaturated and cyclic saturated refrigerants. We see that this compound is a saturated compound. So, the number of chlorine atoms in this case is 2A plus 2 minus B plus C, which comes out to be 2. Hence, the chemical formula for the compound is CHCl2CF3. Let us now discuss few special cases. The first being isomers, which, as we know, are compounds with the same chemical formula but different molecular structure. For chlorofluoro compounds based on ethane, each isomer has the same R number. The most symmetrical one is designated by the number only. As the isomers become more and more unsymmetrical, successive lowercase letters A, B, C, etc. are appended. Let us understand how this asymmetry is measured with the example of dichloro-trifluoromethane. The compound is designated by R123. Now the chemical formula is CHCl2CF3. Now here we see W1 and W2. So W1 and W2 are the masses attached with the first and the second carbon atom. The difference between these two is found. The isomer is considered more unsymmetrical when the absolute value of the difference between W1 and W2 is higher. In the propane series, the isomers are designated by the same R number, but with two lowercase letters appended. Here is an example of dichloro-pentafluoropropane. The first suffix depends on the substitution in the central carbon atom C2. The second lowercase suffix depends on asymmetry, determined by the difference in mass attached to the terminal carbon atoms C1 and C3. These appended letters are omitted when no isomers are possible for a compound. Next, there are cyclic compounds, which have 3 or more atoms arranged in a ring structure. An additional letter C is added to the number as a prefix. Here is an example of octafluorocyclobutane, which is designated as RC318. The prefix C indicates the cyclic nature of the refrigerant. The identifying number is derived using the steps discussed earlier for hydrocarbons. Ethers are a class of organic compounds that contain an ether group, that is, an oxygen atom connected to two alkyl or aryl groups. These are designated with the prefix E for ethers, immediately preceding the number. Let us see an example of dimethyl ether, which is designated as RE170. The identifying number is derived using the steps discussed earlier for hydrocarbons. Cyclic ethers have both C and E prefixes. The prefix C precedes E and is written as CE. Blends are refrigerants consisting of a mixture of two or more different chemical compounds, which are often used individually as refrigerants for other applications. Blends are of two types, zeotropic blend and azeotropic blend. The word zeotrope is derived from Greek words zen and tropos, meaning something which changes as it boils. Adding a Latin negation prefix a gives azeotrope, meaning not zeotrope. Zeotropic blends comprise of multiple components of different volatility, but azeotropic blends comprise of multiple components of the same volatility. Zeotropic blends have constituents which do not evaporate or condense at the same temperature as one substance, but within a range of temperatures. However, in case of an azeotropic blend, at a given pressure, the equilibrium vapor and liquid phase composition are the same. which means that the constituents evaporate or condense at the same temperature as one substance. The zeotropic blends are identified by a number assigned in the 400 series. The azeotropic blends are identified by numbers in the 500 series. Here are few examples of azeotropic and zeotropic blends. When two zeotropic or azeotropic blends have the same constituents but different composition, as is seen in these examples, suffix upper letter A, B, C, etc. are added to distinguish between such blends. Let us now discuss some miscellaneous organic compounds. These miscellaneous organic compounds include saturated hydrocarbons having 4 to 8 carbon atoms, oxygen compounds like ethyl ether, sulfur compounds, nitrogen compounds like methylamine. These compounds are assigned numbers in the 600 series. In case of saturated hydrocarbons having 4 to 8 carbon atoms, the number is assigned as 600 plus number of carbon atoms minus 4. Thus, butane, which has 4 carbon atoms, becomes R600, pentane, which has 5 carbon atoms, becomes R601, hexane, having 6 carbon atoms, becomes R602, and so on. The straight chain hydrocarbons have no suffix. The isomers are identified by suffix A, B, C, etc. Last but not the least, we have the inorganic compounds. Inorganic compounds are assigned identifying numbers in 700 series when the refrigerant has a relative molar mass less than 100, and in the 7000 series when the given refrigerant has a relative molar mass equal to or more than 100. The numbers assigned are given by 700 or 7000 plus the relative molar mass rounded off to the nearest integer. If two or more compounds have the same relative molar mass, the distinction is made by adding uppercase letters A, B, C, etc. as suffix to the identifying number. Here are few examples of inorganic compounds and their identifying number. Hydrogen is assigned 702 as its molar mass rounded off to the nearest integer is 2. Similarly, water is R718. Air, depending on its composition, has a relative molar mass equal to 29. Hence, its identifying number is R729. At the end, we can see carbon dioxide and nitrous oxide. These two have the same relative molar mass when rounded off, which is 44. So to distinguish between the two, a suffix uppercase letter A is added to the identifying number for nitrous oxide. Thank you for watching. Please provide your feedback in the comments below. Also, please like, share and subscribe.